Hello, this is the research methods video on correlation. If I can just remind you as you listen to this video to write the Cornell notes as best you can and also answer the questions that I'll ask as we go through the video. Once you've finished, write this up as neatly as you can into your mind map and have a little look through some of the additional textbooks. Okay, so what's a correlation then? Well, a correlation is a way that we would analyze some data. So we might get two sets of data, and we might want to see if these two sets of data might be related to each other in some way. We can do this with more than one set of data, but usually we'd have two variables we'd be measuring against each other. Now, we could have different types of relationships between these two variables. We could have a positive correlation, which is as one variable increases, the other one seems to go up as well. An example of this could be, say you go to the cinema and you kind of record all the number of people that come into the cinema on each given night, and you plot this against how much money the cinema made on that night. You'd tend to find, if you did a bunch of data points on this, the more people that came to the cinema, the more money the cinema would make, and you'd quite a strong positive correlation there. Negative correlation, which is when one thing that you measure increases, the other variable will decrease. So perhaps an example of this would be if you kind of measured how far you'd gone in the car and fuel use. You'd probably tend to find that as distance traveled goes up, amount of petrol remaining in the tank would go down. Okay, so it's useful to see that we can have positive and negative correlations, but they're quite vague. What we might want to say is the strength of the correlation. And the correlation coefficient gives us a number which is going to indicate the strength of the relationship between these two variables. What you can see here is a set of 5 axes, and I've tried to make it from a perfect negative correlation to a perfect positive correlation. In the center, there's no correlation there. And then the pink and the turquoise is either a weak negative or a weak positive. Okay, so what we can see here now is there's a number line coming from -1 to +1. So very rarely would you get in psychological research a -1 or +1. It would be somewhere between those two values. If it's in the positive part of the graph, it's a positive correlation. If it's the negative part of the line, it is a negative correlation. And the kind of closer they are to 1, the stronger the relationship. Okay, some problems with correlations. Well, you might get two variables and then compare them against each other and find that actually there's a really strong correlation, there's a really strong relationship. That's useful to mention, but there is a small problem, which is we can't state from a correlational research that one variable has caused the change in the other. Okay, there's a few different reasons for this. So one reason is it could be a third variable. It could be something else which has caused the change in the two things that you're observing. Therefore, it isn't one variable caused another, it's a third unknown variable. It could be that it's just been chance. You've just happened to have measured two variables and they just happen to have come up as a correlation. So we can't imply that one variable caused another in the way that we could with an experiment. So what you might want to do is you might want to run a correlational study on some bits of data that are already out there, notice there's a correlation, and then suggest to run an experiment afterwards. So clearly extraneous variables could have caused some of the changes that you've seen. And as I just said, we can make predictions that you can then test in an experiment. This correlation coefficient is a very useful number because it's going to tell us the strength of a relationship. We would gain a correlation coefficient number by putting our information into a statistical test. So Pearson's R would be the stats test that we would use generally for a correlation coefficient. And the closer it is to 1, the more likely we are to say that, yes, we found there is a statistically significant relationship. Okay. What I'd like you to do before you come into class for this one is I'd like you to Google crazy correlations or spurious correlations. There are a lot of things out there which seem where two variables have been measured and there seems to be a pattern that's formed, when actually they're two things that couldn't possibly be a pattern. So just find me a couple of those and that would be great. Thank you.